Welcome to my video on applying Newton's laws of motion to dance. Let's start with Newton's first law, which states an object moves at constant velocity if there is no net force acting upon it. So for example, once a spaceship is launched into space, it does not need fuel to stay traveling in space because there's no net force acting upon it. On Earth, we face forces of friction and air resistance. So if we apply this to a dancer's perspective, friction comes from the dancer's point of contact with the floor. So if a dancer is turning with one foot on the floor and the other in passe, as you can see in this picture, the foot on the floor is moving in circles, causing friction between the floor and the dancer's foot, which causes her momentum to slow. In ballet, dancers often wear pointe shoes. They look like regular ballet slippers, except they have a wooden block where your toes would be. These shoes are made to make it look like the dancer is dancing on the tips of her toes. But it also is made with a small flat circle or oval platform, which makes it much easier for a dancer to do multiple turns, perhaps because there is less friction with a satin-covered box to twirl on. In jazz, dancers typically wear jazz shoes, which are usually black slipper-like shoes that have a slick surface on the ball and heel of the shoe. Many are made with leather, synthetic leather, or neoprene, which cause less friction when turning and allow the dancer to turn more and more easily. This is typical for jazz due to its many turns, but is a challenge for fast footwork because it can be very slippery. That is why jazz dance classes are often done on marley floor versus a slick, polished wood floor like ballet. Newer forms of dance, such as contemporary and modern, require that the dancer dance barefoot. This makes it very difficult for a dancer to turn. Imagine the friction created by the soft, almost sticky bottom of your foot turning against the marley floor. So what happens after time twirling on bare feet is your feet blister and eventually get calloused. Now imagine a calloused foot, which is hard and not sticky, turning on a marley floor. It is much easier. Air resistance, however, is something we have no control over and does not have as huge of an impact on a dancer's friction. Gravity, however, is very important and is responsible for a dancer's capability to balance. The key to balancing is equal distribution of weight on either sides of your line of contact with the floor. For example, here's a dancer in arabesque. Her line of balance is her working leg, which is the bottom leg holding her up. If her leg were to be at a diagonal instead of a straight up and down line, then she would fall. Her center weight must be over this leg. To keep her weight balanced in this position, she must alter some weight forward to compensate for the back leg that is off the ground behind her. She does this while still keeping her line of balance straight up and down over her working leg. And yes, she is thinking about all of this. For those of you who thought dancers had no brains or skill, think again. This is what a typical person looks like doing an arabesque. Okay, so now for Newton's second law, which states force equals mass times acceleration. This is very important in dance because every dancer is different and has to find out what works best for their own body mass. For leaps and turns, the dancer must control his or her energy in order to compensate for their own mass. For example, myself, since I'm short and not very big, I have to put more energy into a turn in order to make it around several times, versus someone really tall with a larger mass would have to use less energy. And finally, Newton's third law states, for any force, there is always an equal and opposite reaction force. It's easy to compare this to leaps when thinking about a rocket. A rocket travels fast due to its amount of gas expelled from its back. When a dancer jumps, the energy and force he or she uses to push off the floor determines how high and far the dancer gets in their jump. If a dancer is aiming completely for height, they would put all their force completely downward, causing them to go straight up. If they wanted to travel farther with their jump, they would direct the force more on a diagonal into the floor, causing them to get a greater distance out of their jump. Usually, dancers want to do both of these at the same time, which makes it very difficult. And that concludes all of Newton's laws of motion applied to dance.